David Can here with another question from topic 5.2. We're going to be solving problems involving potential difference and current, charge, Kirchhoff's circuit laws, power, resistance, and resistivity. In this circuit, the cell has negligible internal resistance. We want to know which of the following relationships between the current through branch 2 and the current through branch 3 and the current through branch 1 is correct. All right. Now the first thing that I notice in the options is that there are 3 currents, but only 2 currents show up in any particular answer, and they're combinations of 1 and 2, 1 and 3, 2 and 3, 3 and 1, combinations of all different different combinations of the 3 currents. So the first thing that I'd like to do is look at those 3 currents, and we see that here's our cell, so we can expect the current to be coming out of the cell. And the current is going to deliver energy to each of these resistors. So we can expect the current to be going down through resistor R and to the left through resistor 2R, which means that I1 has to be supplying both I2 and I3. Remember conservation of charge. If we have a flow at a rate of I1 in and a flow at a rate of I2 out and I3 out, then I1 must be supplying I2 plus I3. Which means that I2 and I3 must each be less than I1. Well, we'll assume that neither one's going to be 0. There's really no reason to expect that each leg of this circuit would have 0 current. So if I1 has to be larger than I2 or I3, then this can't be true. I3 can't be equal to twice I1. So we can eliminate that one. The next thing that I notice is that this branch has half the resistance of that branch. It's easier for electricity to flow through this branch than it is for that branch, so we would expect the charges to prefer this branch. This is like a highway and a country road. People coming in off this road, most of them will take the highway because it's easier. Some of them will take the country road. So there's no reason to expect that I2 will be equal to I3. We might expect I2 to be greater than I3. But because we don't expect them to be equal, it can't be A and it can't be B. Because if I2 is half of I1, then I3 must be half of I1. And if I3 is half of I1, then I2 must be half of I1. So if one of these is correct, then they both must be correct. But neither one is correct. Which leaves C by process of elimination, but why does it have to be C? Well, we can think about it in terms of Kirchhoff's circuit laws. If we form a loop here, then any energy we lose going through resistor 2R, we virtually gain going backwards through resistor R. So basically both circuits have to be equivalent. Both paths have to be equivalent because they meet at these 2 points. If I lose V volts moving through here, I have to lose V volts moving through there. So the 2 voltages have to be equal, which means IR has to equal IR. It's the same R on both sides, just a factor of 2, which means that twice I3 has to equal I2. I2 is twice I3. Twice as much current goes through this branch as that branch.